My dear student, in my previous video, I introduced the topic vector algebra, which is given as the 10th chapter in the CBSE 12th standard textbook. Vector algebra I have introduced in the previous video, and I have given the definition for a vector and a scalar, and examples of vectors and scalar also we have seen, and the various types of vectors we have discussed. Now in this video also I am continue the topic with the definition collinear vectors. In the previous video I have given the definition of parallel vectors. If the two vectors are parallel, their direction and magnitude are same. A, B, C, D are two parallel vectors. They are acting along the same direction and they have same magnitude only, magnitude also. So A and B are two parallel vectors. These parallel vectors are also collinear vectors. Collinear vectors are nothing but parallel vectors and also the vectors acting along the same line. If the two vectors acting along the same line, then those two vectors are called collinear vectors. So this AB vector acting along the same line, therefore the vector A and B are collinear vectors. Parallel vectors are also collinear vectors. Suppose if A is a vector acting along a direction, one direction, and negative A is acting along the reverse opposite direction of vector A, which is denoted by minus A of same magnitude. Here the magnitude is same, but this minus A vector is acting along the opposite direction of A vector, but here also the vector A and minus A vectors are collinear vectors. If they are acting along the same direction or in the opposite direction in a same line, those two vectors are also collinear vectors. So from the diagram, we have seen what are the collinear vectors. See, A vector and C vector are parallel, and D vector is also acting along the same line but in the opposite direction of C. Therefore, collinear vectors are A, C and D. In this diagram, collinear vectors are A, C and D are the collinear vectors because A and C are parallel. D is acting along the same line in the opposite direction of C. So A, C and D are collinear vectors. Similarly, co-initial vectors, then next definition, co-initial vectors. That means two or more vectors having the same initial point is called co-initial vectors. See here, B vector, C vector and D vector. These three vectors having the same initial point. This point, say for example, this is the point A. A is the initial point of B vector, C vector and D vector. Therefore, B, C, D are co-initial vectors. They are having the same initial point. So that's all about the collinear vectors. Next, we are going to see vector addition, addition of two vectors. Vector addition. Suppose two vectors A and B are two different vectors which are acting in two different directions. The next definition is addition of vectors. Addition of vectors. See, A is a vector acting in the direction of AB. Initial point of the vector A is A, capital A, and this is the vector B, which is acting from B to C. and B is the initial point of the vector B. Now, the vector AC, the vector this is vector AC. A is a vector acting on the line AB, B is a vector acting on the line BC, and AC is another vector whose initial point is A and the terminal point is C. So this AC vector is nothing but the sum of the two vectors A and B. This is A plus B. So addition of two vectors, suppose A and B are two vectors, the initial point of vector A is A and the initial point of vector B is B. So AB vector plus BC vector is equal to AC vector. So AB vector is A vector plus BC vector is B vector. So AC vector is A plus B vector. This is addition of two vectors A and B. And this addition is represented by the triangle law of vector addition. That means if two vectors A and B are acting along the two sides of a triangle, A vector is acting along the side of a triangle AB and B is a vector acting on the other side of the triangle BC, then the sum is represented by the third side of the triangle with the initial point of A and the terminal point of B. A and C. In the B is a common point. So AB plus BC is AC, initial point of the vector A and the terminal point of the vector B is AC. That is called A plus B. This is called triangle law of vector addition. This is called triangle law of vector addition. Triangle law of vector addition. If two vectors A and B are represented by two sides of a triangle, then the sum is represented by the third side of the triangle with the initial point of A vector and the terminal point of B vector, small b vector. That is called AC vector. It is nothing but A plus B. This is represented by the sides of a triangle. Sum is represented the third side of a triangle, but not in the direction of AB plus BC. CA is not in the direction, but it is A plus B direction is AC. Initial point of A and the terminal point of B is C. Now suppose if you consider AB plus BC plus CA, if you consider like this, starting with A, AB, BC, CA. CA is now, this is nothing but AA. The starting point you reach AB plus BC plus CA means again you reach AA. Again the addition law, by addition law, first vector initial point, last vector terminal point is AA. It's again same point A, therefore this addition is zero vector. So in a triangle, if you consider the three vectors anti-clockwise direction cyclically, so that is AB plus BC plus CA is zero vector, because CA is equal to, CA vector is equal to minus AC vector, I mean, in the direction. AC is in the direction A plus B, CA is minus of A plus B. Therefore, AB plus BC equal to AC, but AC, CA is minus AC, therefore you know that AB plus BC plus CA equal to AB plus BC, you know, by triangle law, AB plus BC equal to AC. AC plus CA. CA is minus AC, you know, the direction CA is minus AC. Like that you can get zero. So, from this definition itself we can derive, but by the geometrical representation starting with A and reaching the point A again, you will get AB plus BC plus CA is AA, that is 0. So anyhow, in a triangle, if you consider the three sides in the counterclockwise sense, the sum is 0. That is, but in the triangle of vector addition is, if you consider two vectors in the two sides of a triangle, for example, PQR. PQ vector and QR vector are two sides of a triangle. Adjacents of PQ plus QR. PQ plus QR equal to initial point of the vector P and the terminal point of the vector QR is R. Therefore, this is nothing but this common point is eliminated, equal to PR. PQ plus QR equal to PR. Initial point of the first vector and the terminal point of the second vector. PQ plus QR. You eliminate the common point, you will just get PR. So this is PR vector is the sum of the adjacent sides of the two triangles. This is called a triangle law of vector addition. Next. Next, properties of, also before that, you will consider a vector A vector plus 0 vector equal to 0 vector plus A vector equal to, simply you will get A vector. So this 0 vector is called additive identity vector. This 0 vector is called, 0 vector is additive identity. You will call that 0 vector by, because any vector adding with the vector 0, you will get the same vector. A plus 0 equal to 0 vector plus A vector equal to A vector. Therefore, 0 vector is called additive identity. Similarly, A vector plus of negative A vector equal to negative A vector of plus A vector is equal to 0 vector. A plus minus A is 0, minus A plus A is also 0 vector. This is minus A is called additive inverse of vector A. Minus A vector is the additive inverse of vector A. Additive inverse of vector A. These are some properties of vector addition. Next, properties of vector addition. Properties of vector addition. Suppose we will consider the two vectors. AB vector, BC vector. You consider vector AB by A vector and vector BC by B vector. Then by triangle law, you know AB plus BC equal to AC vector. That is nothing but, you know that AB vector plus BC vector is AC vector. This is nothing but A plus B vector. By triangle law, if you complete a parallelogram, if you complete a parallelogram ABCD, A vector is acting along the vector line AB and B vector is in the side of the parallelogram BC. In a parallelogram, you know the opposites, you know the parallelogram property. Opposite sides are parallel and equal, therefore this vector is B vector and DC is parallel to A vector, therefore this is again A vector. So this is called, if A vector and B vector are two adjacent sides of a parallelogram, then their sum is nothing but the diagonal of the parallelogram AC. AB, BC are two adjacent sides of a parallelogram, then the sum is the diagonal of the parallelogram AC, and this is called parallelogram law. Parallelogram law of vector addition. Parallelogram law of vector addition. If A vector and B vector are represented by two sides of a parallelogram, if you complete the parallelogram ABCD, AD vector is again parallel to BC, therefore B vector, and DC is equal to parallel to AB vector, therefore it is A vector, and the direction of DC and AB are same. Similarly, AD and the direction of BC are same and equal magnitude, therefore AD is B vector and DC is A vector. So above in this triangle ADC, AD plus DC, AD plus DC vector equal to AD plus DC vector equal to, again D is a common point by triangle law, AD vector plus DC vector equal to, again by D common point we eliminate, will get AC vector, again AD by using the upper triangle AD plus DC equal to AC. This is nothing but AD is B plus DC is A. So the same AC vector is again expressed by B plus A. The same AC vector is again, by considering the upper triangle, it is nothing but B plus A. So A plus B is equal to B plus A. By this parallelogram law, we can find one property, that is AC. First AB in the lower triangle AB plus BC is also AC. AB is A vector, BC is B vector. So A plus B equal to AC vector. AB plus BC, AB is A, BC is B, therefore A plus B is AC. Similarly, B plus A is also AC. So AC is represented by both the vectors A plus B and same as B plus A. Therefore, A plus B, therefore A vector plus B vector equal to A vector plus B vector equal to B plus A vector, B vector plus A vector. This is called commutative property. A plus B vector equal to B plus A. This is proved by parallelogram law of vector addition. So A plus B equal to B plus A. This is called commutative property of vector addition. Commutative property of vector addition. And one more property, associative property. Another property is that next property, associative property. Associative property. Suppose if you find three vectors A, B, C, A, B and C, or any three vectors, associative property indicates that A vector plus B vector plus C vector is equal to A vector plus B vector plus C vector. You can associate like that. A plus B plus C vector equal to A plus B plus C vector. you can associate these three vectors like this. This property is called associative property of vector addition. And your proof for this is not necessary. Commutative property is reversible addition. This is associative property of three vectors. And also I have explained already additive identity and additive inverse. Thereby I will conclude this video and we will continue the remaining topic in the next video. Thank you.